Okay, we're in section, no we're not, 4-2. The good news, I was asked yesterday whether or not the videos I'm making should be public or private. And we decided to make them public because we're getting free space from Google and they want more lectures on their free site. So it doesn't matter to me. But that means that if you ask some question and the computer catches it, then you'll be immortalized at some Google spot in differential equations. You'll be known as, the students that did 4-2 or something. All right, now number 14. Let's hope for the best. You will have a problem like this on your test where you have multiple equations and you have to solve them. So that's the good news. So last time we were so wonderfully involved in what we're doing, we failed to write the equations down right, which of course meant that there was no way I was ever going to get the right answer, which of course I didn't. Okay, so that looks like I may have written that problem down correctly. And then x of 0, y of 0 is 0, and x prime at 0, y prime at 0 is -1. So anyway, you have to have initial conditions. They have to be at 0, otherwise you can't solve the problem. Okay, so we're going to take the Laplace transform of both equations, both sides, while applying the initial conditions, while having them memorized because we can't see them. All right, so I've got s squared x of s plus 1 plus 2s x of s plus 4 y of s is 0. I have s squared y of s plus 1 plus x of s of x plus 2 y of s is equal to 0. I'm using equation number 3 on the double prime guy and equation number 1 on that guy, and in fact I have it wrong naturally because there's no s there. Okay, so I luckily I could correct that. Now, assuming that I did that right, we're now going to align these guys so it looks like I have something like that looks like 3x plus 4y plus y is equal to 2 and x plus 2y is equal to 4. We're going to align the two equations so they look like that, so I have two equations, two unknowns is what I'm looking for. Okay, so I've got s squared plus 4 no, s squared plus 2. Okay, so I'm going to have to get my head in the problem so I don't mess it up too badly, because if I mess it up too badly, there's no way we're going to get the right answer. Is equal to 0. And then I've got x of s plus s squared plus 2 y of s is equal to 0. Okay, now I'm going to use Kramer's rule and solve for x of x. So x of s equals, and I messed it up already. Okay, so there's a -1 that goes over there, there's a -1 that goes over there, right? Yeah. So -1, -1. Okay, so I got that. Is equal to, well, -1 -1 for s squared plus 2 divided by s squared plus 2 for 1 s squared plus 2. Now, because this is for posterity, we're going to have to make that equal sign look better, right? Okay, so on the top I have a minus s squared plus 4 and I've got a plus 4. So I'm going to have a minus s squared minus 2. Okay, so I got minus s squared minus 2 plus 4. So that'd be a minus s squared plus 2. Okay, so that looks good. On the bottom, I have s squared plus 2 squared minus 4. Okay. So I have a minus s squared minus 2 divided by, this is s squared plus 4s plus 4, right? Plus 4 minus 4, so they go away. S squared times s squared plus 4. Okay, I hope that's right. Now I'm going to go y of s. Y of s equals, on the bottom I'm going to keep the same, s squared plus 4, and on the top the minus 1 goes there, the minus 1 goes there, and I'm going to have s squared plus 2, 1. Okay, so I'm going to have minus s squared minus 2 plus 1 would be minus s squared minus 1, I think. This is minus 2. No, that's going to be plus 1. S squared plus 1.
Okay.
This is 1. That's minus 2, giving me a minus 1. Okay, that looks good. Over s squared plus 4. Someone's looking at the board like maybe I'm not right.
Well, I just have a quick question. If you're solving for ys, why are you using the excess column numbers on that side?
Okay, when you solve for when you solve for x, the x column gets what's in the other side of the equal sign, and the y column stays. When you're solving for y, the y column is replaced by what goes on the other side of the equal sign, and the x column stays.
That makes sense.
Okay. So now everybody's happy. If it checks, everybody's happy. So x of s is minus s squared plus 2 over s squared plus 4. Okay, so we're going to do a partial fraction, a over s plus b over s squared plus cs plus d over s squared plus 4. Okay, so when we do the partial fraction, I have a repeating guy there. I take it s, and then I take it s squared, and I don't increase the denominator any. Okay, I have a if I go and reconstitute my denominator, my numerator looks like a s cubed plus 4as plus bs squared plus 4b plus cs cubed plus ds squared, which may or may not be right. I don't know. It looks pretty good. All right, so now I look at the s cubed. Is that an s cubed term?
That's what you said.
Yeah, I know. I said s cubed, and it would have to be an s cubed term. All right, so the s cubed term looks like a plus c. Is there an s cubed term? No. So that has to be 0. There's an s squared term for a plus b plus d, and that has to equal -1, I think. -1. Oh, yeah, -1 is correct. Then there's the s term for a, and that has to equal 0. And then there's the unit term for b, and that has to equal, 4b has to equal 2. Alright, well, that makes it easy, I guess. This sort of implies that b is a half, and that implies a is 0. And if a is 0, then c has to be 0. And if b is a half and a is 0, then d has to be -3/2. Alright, so that being the case, I'm going to have x of s is equal to 1/2 over s squared minus 3/2 over s squared plus 4. Okay, so that looks good. Alright, well, I'm going to manipulate some. I look at my Laplace transform table. I don't like 3/2 over s squared plus 4, but I'd really like to have 2 over s squared plus 4. So I'm looking at number 8, and I'm saying, well, if this were 3/4 times 2 over s squared plus 4, wouldn't that be wonderful? And then this s squared guy looks like number 6. Looks like number 6. But in order for it to be number 6, I need to have a 2 on top. Okay, so I need to have a 2 on top. So I'd have to have 1/4 2 over s squared. No, I don't have to have that. It's number 5, not number 6. Number 5. So all I need is 1 over s squared times 1/2. Alright, so now I can go and do an inverse Laplace transform and come up with a x of t is equal to 1/2 t minus 3/4, it doesn't look like a 3, minus 3/4 sine 2t. Okay, before we continue, we're going to look at our initial conditions. X of 0 is supposed to be 0, and it is. Check. X prime of t is equal to 1/2 minus 3/2 cosine 2t. X prime at 0 is supposed to be -1. It is. Check. So we're not sure that that's the real solution yet, but at least it passed the initial conditions. So the first idiot check, it passed. We'll have to check it more later. But if it didn't pass that check, then we know we can't go on. All right, so now we go back to y of s. So y of s is minus s squared minus 1. Y of s minus s squared minus 1 over s squared plus 4. Okay, so now we're going to do the same thing, do a partial fraction thingy. I'm going to have A over S, B over S squared, CS plus D over S squared plus 4. And then we're going to uncommon denominator it. And on the bottom, I'm going to have S squared plus 4. And on the top, I'm going to have A S cubed plus 4S A plus BS squared plus 4B plus CS cubed plus DS squared. Okay. I then are going to look at the S cubed term and see that A plus C is 0. I'm going to look at the S squared term, and I'm going to find that B plus D is minus 1. I'm going to look at the S term, and I'm going to see that 4A is equal to 0. I'm going to look at the unit term, and I'm going to see that 4B is equal to minus 1. Okay, and this is going to imply that B is minus 1 over 4, A is 0, C is 0, and D is, okay, if that's minus 1 over 4, minus 3 over 4. Okay. So after chapter 3, it doesn't, we use a whole sheet of paper on a problem, doesn't matter, right? Because that's half the number of papers, so perfectly okay. So I'm going to have minus 1/4 over S squared minus 3/4 1 over S squared plus 4. Okay, I recognize this as number 5 again, and I recognize this guy as somebody that could be number 8 if I do it right. So I'm going to manipulate my numbers around just a little bit. Minus 1/4 1 over S squared minus 3 over 8 2 over S squared plus 4. Now I'm going to apply number 5 and number 8 to my Laplace transform table, not the one in the back of the book, but the one that's passed out to you, and get that y of t equals minus 1/4 t minus 3/8 sine 2t. Now I'm going to check the initial conditions. Y at 0 is supposed to be 0, check. Y prime of t would be minus 1/4 minus 3/4 cosine 2t. Y prime at 0 is minus 1, check. The initial conditions work. Okay, so we're going to take the easy way out and look at the back of the book and see if the back of the book agrees with our glorious answer, and we know it better. Otherwise, we're going to be extremely happy with the grad student that made the answers up in the back of the book, because we know we're right, right? 14. 1/2 x of t is supposed to be x of t. Where did it go? There it is. It's supposed to be 1/2 t minus 3/4 sine 2t. Brilliant. The grad student agrees with us. Y of t is supposed to be minus 1/4 t plus 3/8 sine 2t. Check. Okay, excellent. Now we look in the syllabus, and what does it say? It says that in this particular section we are working problems up to 23. Okay, so if we do problem number 20, oh, it looks like I have the wrong syllabus. How is that possible again? Yes, that's the wrong syllabus. Let's see if I can find the right syllabus. Okay, there's the right syllabus. Up to problem number 23. Excellent. All right. So should we do 16 or 18? I guess we should do 18. Apply theorem 2. Okay, so we would do 18, except 18 says I have to apply theorem 2. So that means I have to go figure out what theorem 2 is. And that corollary, I found theorem 1. Theorem 2. All right, so theorem 2. Why would I want to do that? There's absolutely no reason I'd want to apply theorem 2 to these problems. Now I'm going to do the problem without theorem 2, and then we're going to do it with theorem 2, and then you're going to tell me whether or not anybody in his right mind would solve these with theorem 2. All right, so here's f of s is equal to 3 over s plus 5. I'm going to do a partial fraction, a over s plus b over s plus 5. I'm going to unpartial my fraction and get f of s is as plus 5a plus bs over s plus 5. And then I'm going to say my s term is a plus b, which has to be 0. And my unit term is 5a, which has to be 3, which implies a is equal to 3/5 and b is equal to minus 3/5. So f of s is 3/5 over s plus minus 3/5 over s plus 5. I ran out of room. Then I'm going to use number 4. Number 4 on that guy, and number 7 on that guy, and we're going to write that f of t is 3/5 minus 3/5 e to the e to the minus 5t. Okay. All right, so that's what that is what I would do if I wasn't going to use theorem 2. Now I'm going to use theorem 2. I don't know if I can even spell theorem 2. But theorem 2 says the inverse Laplace transform of f of s over s is equal to the integral 0 to t of f of tau d of tau. Well, I don't see how we can possibly do that. I don't see how that's possible. Okay, let's look at the other one. The Laplace transform, 1 over s. 1 over s. The Laplace transform of f of t is equal to f of s over s. Well, isn't that just totally brilliant?
Well, because you didn't make it to the surface first, so it goes in. First thing you want to do is put it on top. So you need to do a mate on that one class with that bottom on the.
Well, I have absolutely no idea why I'd want to do that.
Well, no, it didn't do it.
And I even have less of an idea. Okay, all right. Maybe I have some idea. Maybe I'm overreacting to the obvious stupidity of this problem. Okay, now, I have, if I have f of s over s, then that implies in this problem that f of s is 1 over s plus 5, which further implies that f of t is e to the minus 5t. Okay. Now that being the case, 1 over s plus 5 has the inverse Laplace transform, has to equal the integral 0 to t of e to the minus 5t dt, except now we have the stupidity of having the same variable, and we can't do that. So we have to make this guy a tau and that guy a tau. All right, now we're okay. Now, what's the integral of, what's e to the minus 5t? So it'd be minus e to the minus 5 tau over 5 evaluated at 0 and t. So that would be minus e to the minus 5t over 5 plus 1/5. Is that the answer I have? I have 3/5.
I'm going to have to go
Life is that way. Okay, so who are we going to believe? Theorem 2.
Well, it's practical.
Or are we going to believe the instructor's brilliant solving of theorem of the problem without using theorem 2? Which one? And what problem are we working? Anybody know?
18.
18? The instructor is correct. All right, so the instructor is correct. The back of the book agrees with the instructor's brilliant answer. So what is our problem here? Why?
Like I'm missing a 3 somewhere.
Yeah, how do we miss a 3 out of there? I don't know how you miss a 3 out of there. It takes real talent. Oh well. Now there's no constant of integration. So how in the world do we get a t out of it? 1 over s, Laplace transform of this is that. That over that has to be the whole thing. That has to be that. That has to be that. There's no doubt about that. And when I do this integral, there's no 3 anywhere. There just isn't any 3 anywhere. Okay, enough of the silliness of the math people. All right, moving on to section 4.2, 4.3. That's what we'll do. Okay, section.
I gotta get that over there. So try
This
to
is
do that.
supposed to be a fun chapter, in case anybody was wondering. So difficult problems like that are things that we don't do. All right, now, if we look in the syllabus, which of course I've lost again, misplaced the syllabus. Oh, found it again. I have the 4-credit class syllabus, it's not this one. All right. We're supposed to do 27 through 39 on. 27 to 39 on. Now, why in the world wouldn't we do the beginning ones? Probably because if you do 27 through 39 odd, then you would have to have done the things that came before, and it's like doing them twice. So that's why we don't do the things before, because we're going to do them now. Okay, that answers that question. So we have today and next week to do 28, 30, 32, 34, 36, and 38, right? And then when I get done with them, then we can take the exam. So if I get done with them on time, then we take the exam on time. If I don't, then we'll just have to take it late. That's just the way it is. All right, so 28. X double prime minus 6x prime plus 8x. And all of this will depend on my ability to copy the question right out of the book. Because if I don't do that, then life will be not as easy as one would want it to be. Like right there. I did it already. All right, so did I write the question down right? The answer is yes. All right, so we're going to do a Laplace transform of everything. So I got s squared x of s, everything that trails is a 0, minus 6 x of s, 6s of x, plus 8 x of s is equal to 2 over s. Okay, so I got s squared minus 6s plus 8 x of s is 2 over s. I got x of s 2 over s over s squared minus 6s plus 8. Okay, so I'll rewrite it as 2 s squared minus 6s plus 8. Okay, and now I'm going to check out my Laplace transform to see if I have anything that looks like that, and of course not.
It's 13.
You like 13? No, not 13. I need 13 over. All right, so now I'm going to do a partial fraction. So I got a over s plus b s plus c over s squared minus 6s plus 8. And then we'll ask the question, is that guy factoring down there? And the answer is no, he doesn't. So we'll probably have to complete the square on him sometime, but not today. You know, sort of like the King's speech in the Lord of the Rings. Not on this day. We don't have to do that. All right, something like that. All right, so I got an a s squared minus 6as plus 8a plus bs squared plus cs divided by what I got on the bottom. Is equal to, no equal to, get rid of the equal to. Alright, so now we're going to look at the s squared term. A plus b is equal to 0. Then we're going to look at the S term, minus 6a plus c is equal to 0. And then we're going to look at the unit term, 8a is equal to 2. 8a is equal to 2. Excellent. Oh well, we could use Cramer's rule if we wanted to, or we could say A is 1/4, B is minus, this is called by inspection, B is equal to minus 1/4, and C is equal to 3/2. 3/2. Okay, so now I've got, what do we got? X of x. X of s equals 1/4 over s plus minus 1/4 s plus 3/2 divided by s squared minus 6s plus 8. Okay. So I know what that guy is. That's number 1. So this isn't going to be a problem. This is number 1. I look at that guy and I say, what am I going to do about him? Oh, I can factor him s minus 4, s minus 2, right? I could. And if I did, that would be, if I can factor them, then that's number 14. That's a number 14, and that's a number 12. So this guy's going to be a number 12 and a number 14. And all I got to do is factor the bottom. Okay, so on this guy I've got 1/4, 1 over s, plus, actually it's minus, minus 1/4, and I've got s over s minus 4, s minus 2. And then I've got a plus 3/2, 1 over s minus 4, s minus 2. Okay, I'm almost there. I can feel myself almost being there. Now I look at number 12, and number 12 has s minus a, s minus b, and so a is 4, b is 2. I'm looking at the wrong guy. I'm looking at 14 with an s in it. Okay, so a is 4, 4 minus 2 is 2. So I want a 2 on top. So minus 1/8 2s, s minus 4, s minus 2. And then over here, I'm going to also want a 2 on top, so that's going to be 3/4 2, s minus 4, s minus 2. And then over here I still have the 1/4 1 over s. Okay, so I'm using number, what, to do this one? Number 4 to do that one. And I'm using the guy with the s on top. I'm using number 14. And this one I'm using number 12. Okay, so that's what I'm going to do. I'm going to take, this is x of s, take inverse Laplace transform of everything I see. X of t equals, this is an s, not an 8. Yeah, so 1/4 minus 1/8 times. Okay, so number 14 is going to be A, which is 4, or e to the AT, 4t, minus B, which is 2, e to the BT, which is 2t, plus 3/4 times, and this is just going to be e to the 4t minus e to the 2t. Okay. X of t equals 1/4. Alright, so I got 3/4 and I got minus a half, so that's going to be minus 3/4, no, minus a half, so that's going to be plus 1/4 e to the 4t. I've got plus a quarter minus 3/4, so it's going to be minus a half e to the 2t, and that's going to be my final answer. Only good if it checks. Alright, so I'm going to look at x at 0 is 0. Check. X prime at 0. Well, I don't know what x of 0 is yet, so I can't do x prime at 0. Alright, so x prime at t, that's 0. This is 1 e to the 4t minus e to the 2t. X prime at 0 is 0. Check. Excellent. And now we need a second derivative of t. 4 e to the 4t minus 2 e to the 2t. Okay, what was that problem? Are we working that problem? I want one of those. I want minus 6 of these. And I want 8 of the original guy. And when I get done, I want 2. Okay, that's what I want. Alright, so I've got a 2, so that's good. I've got 2 e to the 4t minus 6 plus another 4, so I got plus 0 e to the 4t. That's a good thing. And then I've got minus 4 plus 6 minus 2, 0 times e to the 2t. The whole thing checks, so I got the right answer. Okay? Excellent. Good enough? Make sure you do the odd ones. That makes life better. Number 30. X double prime, 4x prime, 8x e to the minus t. X at 0 is the same as x prime at 0, which is the same as 0. I like that one. That's good. Laplace transform of the whole thing. S squared x of s. 4s x of s. 8x of s equals e to the minus t. Okay, that'd be 1 over s plus 1. 1 over s plus 1. I hope. Yeah, that's what it is. All right. Getting like terms together, s squared, 4s, 8 x of s, 1 over s plus 1, x of s 1 over s plus 1 s squared plus 4s plus 8. Looks like a partial fraction again, unless I can see that in my Laplace transform table someplace, which I do not. Okay. So now I'm stuck with a partial transform. A over s plus 1 plus b s plus c s squared plus 4s plus 8. And so I got a common denominator s plus 1 s squared plus 4s plus 8. And on the top of the numerator, a s squared 4as a 8a plus bs squared plus bs plus cs plus c. Okay. Right, so the s squared term, a plus b is 0. The s term, 4a plus b plus c is 0. The unit term, 8a plus c is 1. Okay, now we solved these using Cramer's rule, right? And we've done it by just guessing and things like this. So now we're going to do something different. I have several years ago I made up an Excel spreadsheet that solves simultaneous equations. And with the appropriate bribe, which is a can of Coke Zero, I will put it on the website. I'll probably put it on the website anyway. So we're going to go and open a file, and it's probably going to be on the U drive. And I wonder where it's going to be. It's probably going to be under math. You think it's going to be under math? That'd be the good spot to go first. Math. And seeing that it's an Excel spreadsheet, oh, look at that. 2 equations to 3 equations. Yep, there we go. There we are. Okay. So now all we have to do is remember what the equations were. All right, so 1a, 1b is 0. Okay, so 1, 1, 0. Turn on editing. Stupid computer. 0. Okay, so there's my first equation. Second equation is 4, 1, 1 is 0. Okay, so 4, 4. Now, how come I've been hiding this from you guys anyway? Yeah, no idea. Typical math person, though, would have something and not tell anybody about it, right? And the last guy is 8, 0, 1, 1. 8, 0, 1, 1. Well, looks to me like the answers are 1/5 minus 1/5 and minus 3/5. Yeah. So A is 1/5, B is minus 1/5, and C is 3/5. Was it 3/5 with or without a minus sign? With a minus sign. Yeah, minus 3/5. And we'll do an idiot check. Yep, that's 0. That doesn't look like 0. Oh, wait a minute. 8/5 minus 3/5, that's 1. Yeah, I guess that one's right too. And this guy is minus 5. This can't be 0. Oh, wait a minute. Well, 4/5 and then minus 4/5 there. Okay, so the Excel spreadsheet was correct. I do like Kramer's rule better, don't you? Yeah. So like I say, yeah, if you see it on the website, you know I put it there.
Is it
And
available for tests?
huh?
Is it available on tests?
Well, if I put it on the website, and then you had these computers on, and you could get it off the website, I don't see why not. I've used Maple before, right? But you don't have Maple, so. Anyway, back to what we're doing. A, which is 1/5. So x of s is equal to 1/5 over s plus something. 1 minus 1/5 s plus 3/5 over s squared plus 4s plus 8. Okay, now does this guy factor? No, he doesn't factor. Alright, so if he doesn't factor, then we have to complete the square. Tell me that you can complete the square without me telling you how to do it. You know how to complete the square? Minus 1/5 over s plus 3 over 5 s squared. So I take the s term, I divide it by 2, and I get a 2, and then I square it, and I get a 4. Okay, so it's going to be s plus 2 squared, and who put that other guy there? So I go, and then I have to borrow 4 from this guy, so that'd be plus 4. Okay, are those guys the same? S squared plus 4s plus 8. 4 plus 4 is 8. Okay, so I got the same thing. So if you can't complete the square, you're hosed. I'm sure it'll come back to you though, because yeah, I am so I take this guy and I divide it by 2 and I square it and I put it here and I subtract it from there, and then I factor s squared plus 4s plus 4 to get that. Want me to do that slowly 3 more times? No? Okay. Karen doesn't care. Her calculator will tell her anyway. Just complete the square on TA89. Partial you figure out how to do partial fractions on TA89 yet?
Not yet.
Well, you better. You better. You just tell it to go you'll give you the partial fraction and it'll give it to you. Anyway, so back to where we're going. Alright, so this guy here looks like number 7. And this guy here looks like I've got a 9. And I've got a 11 maybe. A 9 and 11 both sitting in there. Number 9. Number 11. Alright, so that's what I'm going to do. I'm going to try to manipulate these things. 1/5 1 over s. Nothing like bad penmanship. S plus 1. Alright, now for number 12, not 12, which one do I want? For number 11, I want s minus a. And a is going to be a minus 2. Okay, so it's going to be s plus 2 on top. So I want an s plus 2 on top. S plus 2 divided by s plus 2 squared plus 4. Now, how am I going to get that? Okay, so if I bring out the 1/5, okay, so I got minus 1/5. Okay, then I've got s plus 3 on top. So that means I've got a 1 over s plus 2 squared plus 4 left over. All right, now I look at number 9 and I see that I don't want a 1 there, I want a 2 there because the k is squared, so I got a 4 and the square root of 4 is 2, so I want a 2 on top. So I'm going to put a 1/2 in front and I'm going to put a 2 on top. And now I have the answer. This guy's coming from number 11. This guy's coming from number 9. This guy's coming from number 7. And I'm going to take the inverse Laplace transform of everything. Okay, so x of t equals 1/5 e to the minus t minus 1 over 5 times. Okay, looking at number 11, I have e to the minus 2t cosine 2t. And then I've got plus 1/2. Looking at number 9, I have e to the minus 2t sine 2t. Okay, so now I'm coming down to final answer. X of t 1/5 e to the minus t minus 1/5 e to the minus 2t cosine 2t minus 1/10 e to the minus 2t sine 2t. Okay, time to check our work. X at 0 had better be 0. Otherwise, we're wrong. 1/5 minus 1/5. Check. X prime of t minus 1/5 plus 2/5 e to the minus 2t cosine 2t minus 2/5 e to the minus 2t sine 2t, except that's going to be positive, isn't it? Because it's minus, but the derivative of cosine is going to be minus, so it's going to be positive. Plus 1/5 e to the minus 2t sine 2t minus 1/5 e to the minus 2t cosine 2t. X prime at 0 had best be 0, otherwise we're going to be very unhappy. 1/5 plus 2/5 minus 1/5 is 0, so we're very happy, and that's probably the right answer, so we won't have to do anything else. All right, so that was number 30. So number 32, you look at number 32 yet? Number 32. All right. The fourth derivative minus x at 0, minus x is equal to 0. X 0 is equal to 1. X prime 0 is x double prime 0 is the third derivative at 0 is all 0. Yeah, And then, luckily we have plenty of time. 10 minutes. 10 minutes should be plenty of time, right? I mean, really. All right, so what is the Laplace transform of the fourth derivative? S to the fourth x of s minus s cubed minus x of s is 0. X to the fourth minus 1 x of s is equal to s cubed. X of s is equal to s cubed over s to the fourth minus 1. Okay, so now we ask ourselves, do we have a Laplace transform that looks like that? And I don't see it. Anybody else see it? No, I don't see it. Okay, so we got to do some 9th grade algebra things. All right, so I look at s to the 4th minus 1, and what I see is s squared plus 1, s plus 1, s minus 1. Is that what you see? The difference of two squares, and then the difference of two squares again. Okay, so that's what I see. All right, so I'm going to do a partial fraction. as plus b over s squared plus 1 plus c over s plus 1 plus d over s minus 1. This is the perfect time to have a 4-equation, 4 unknown spreadsheet on your computer ready to go, right? Yes, it could very well be. It's hard to say, but it could very well be. All right, now, if I multiply those together, I'm going to have s squared minus 1, right? So I'm going to remember that. All right, so here we go. Putting everything back underneath where it belongs. We're going to have as cubed minus as plus bs squared minus b plus, I can do this in my head, cs cubed plus minus cs cubed minus cs squared, cs cubed minus cs squared minus plus cs cubed plus minus cs squared. I was right the first time. Minus cs squared plus cs minus c, which means I just ran out of room. Luckily, this is a smartboard presentation thingy, so we should be able to grab what we need to grab and just move it down some and give us some more room, right? Oh, come on. I know you can do it. Perfect. Now, the d term is ds cubed plus minus ds cubed minus ds squared, ds cubed plus ds squared plus ds plus d. All right, now assuming that I did that right, the s cubed term is A plus C plus D, which is going to be 1. And the S squared term is B minus C plus D, which is 0. And the S term minus A plus C plus D, which is 0. And the unit term is minus B minus C plus D is 0. Okay, cooking with gas, everything's fine. Come into our glorious spreadsheet, see if I can make it so I can see everything at the same time. Okay, so there's 4 equations, 4 unknowns. And there are my 4 equations, 4 unknowns. It'd be nice to be able to get both of them in the pane. This is a pane issue, in case you're wondering. Okay, so I've got a pane issue here. Okay, I can get most of them. Okay, so A is 1, B is 0, C is 1, D is 1, E is 1. Okay, next guy, A is 0, B is 1, C is minus 1, D is 1, that guy is 0, A is minus 1, B is 0, C is 1, D is 1, that's 0, and the last equation we can't see. Last equation, 0 minus 1 minus 1 1 0. Well, I would say I got 1/2, 0, 1/4, 1/4. 1/2, 0, 1/4, 1/4. 1/2, 0, 1/4, 1/4. This is going to be over S squared plus 1 plus what? 1. This is over S plus 1. That's over S minus 1. Oh, lucky guess. F of S. Okay, now we go check out the Laplace transform tables. S squared plus 1, that looks like a number 8. And these guys look like number 7s. What could be more easier than that? Okay, so now we're going to manipulate some. I'm going to have F of S equals 1/2, 1 over S squared plus 1, plus 1/4, 1 over S plus 1, plus 1/4, 1 over S minus 1. I hope the initial condition was 1 for x of 0. Yes, it was. Yes, it was. Okay, good. Because if it's not, then I'm... but it is. I'm pretty sure it is. But, okay, so f of t equals 1/2 sine t, sine t plus 1/4 e to the minus t plus 1/4 e to the t, and now my initial condition doesn't work. Darn. Don't we just hate it when that happens? Oh, but A is an S. A is an S, so there's an S that goes right there. There's an S that goes right here, and this is not that guy. This is number 10, which makes him a cosine guy. And my initial condition checks. F at 0 is 1 check. Yeah. Now all they have to do is take 4 derivatives followed by checking every initial condition. But we're out of time, so I just check the back of the book. 4, 3, number 32. 4, 3, number 32. Okay, so I got 1/2 hyperbolic cosine t. Cosine t. That's exactly what I have, right? No sweat. Yeah, I forgot I could put it in a hyperbolic whatever thingy. Okay. Thank you very much.